back to another video of Daily LeetCode Challenge Streak series, and in today's video we have a LeetCode easy question that says climbing stairs. Now let's see what the question says. You're climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? Now, what does the question mean? Let's break down the question. So, the question says you'll be asked to reach n steps. Like you'll be asked to climb 3 floors or 4 floors or 5 floors. Now, each time you can either take 1 step at one time or 2 steps in one go. Now, the question asks, in how many distinct ways can you climb to the top? For example, n is equals to 3. For example, you were to climb to the 3rd step. Okay. Now, if you were to start from the 0th position, how many steps would it take? How many distinct ways would it take? Now, the first thing is you either climb 1 step, then take another step and take another step. So, it will be like 1 plus 1 plus 1. Now, what's another way you can climb? You can take 1 step once and then 2 steps in one go. So, 1 plus 2. Now, what is another way in which you can climb the staircase? It is you can take 2 steps in one go and then 1 step again. Okay, so in three different ways, you will be able to reach the nth stair. Now, the question is as simple as that. Given a step n, in how many distinct ways can you climb to the top? Okay, in how many ways you can climb to the top from 0 to nth step. Now, what can we do here? What can we do? Now, just remember that whenever you are asked something like in how many distinct ways or what is the best possible way or return the minimum number of this or return the maximum number of that, just remember that whenever such type of questions are asked, you're supposed to apply recursion. Okay, you're supposed to apply recursion because if they're asking something like try every possible way, you're trying, if they're asking a number of distinct ways or this thing, you're trying every possible combination, you're trying every possible way to get to the best answer. So if it's number of distinct ways, if it is number of distinct ways, you are trying out every possibility and taking the sum of it. So if you have seen here, you tried every possibility and you took the sum of it. Okay, you took the sum of it. So you will be applying recursion. Now, how to apply this recursion? Usually, if you were to apply recursion for something, what you will do is that you will consider a function. Okay, you will consider a function, and whatever logic is there, you will write it within the function and return the answer in the form of summing all the possibilities. Okay, you will sum all the possibilities. Now, let's break this down. This says f of n. Now, assuming we want to reach to the third step, what are we supposed to do? We are supposed to start from 0, correct? We are supposed to start from 0. Since we are supposed to start from 0, now first I have to know how to reach to point 1. After that, I have to know how to reach to the step 2. Now, if I know how many ways it takes to reach to the step 1 and step 2, I will also be knowing how many steps it will take to reach to the step number 3, because it will be sum of the previous ways. That's it. Okay. Now, assuming I want to write this as a function. Now, whenever you're applying recursion, make sure that you break down this problem in the form of indices. Okay, nothing but index. So you write anything that should be written in the form of index. You should solve in the form of index. Now, you have f of n. Now, What is the base case for any recursion problem? There's supposed to be a base condition that will stop the recursion. What is recursion? Recursion is nothing but the calling of the same function again and again. You will not write a same function 100 times within the same function. Instead, you will call the same function. So you will be calling the same function. This is called as recursion. What will you be doing next? What will you be doing? You will be here, since you can either take one step or two steps, you will be returning the number of possible ways to get to the previous step and the previous step. Okay. Now, assuming that f of n is the number of ways it takes to get to the point n, nothing but to get to the nth step, f of n is the number of distinct ways it will take to reach to the point n. Then what will the function to reach the previous step be? What will the function to reach the previous step and the step before that be? If the number of ways to reach to the point n is f of n, then the function to reach to the point, it will be nothing but f of n minus 1. And what will be the function to reach the step before that? It will be f of n minus 2. It will be f of n minus 2. Now, every time you want to calculate this step, you are supposed to add the sum of the previous and its previous possibilities. So what will we be returning? You will be returning f of n minus 1 as in the previous step plus its previous n minus 2. Okay. Now, what is the base conditions? What are the base conditions that we can think of? First base condition is that if we are at step 0, we have nowhere to move. Correct? We have nowhere to move. So we will be standing there itself. So if at all n is equals to 0, then we'll be returning 1. Because we don't have anywhere to move, we'll be standing there only. So there's only one way to stand there, correct? Now, what else can we think of? Now, if you were to reach to the step 1, if you were to take step 1, and if you want f of 1, what do you have to do? If you want f of 1 here, then you have to check f of 1 minus 1 plus f of 1 minus 2, correct? But f of 1 minus 2, how much is it? It's minus 1. It's a negative value. It doesn't exist. But for you to reach to the step 1, there's only one way in which you can reach. It's just one step that you'll take. So, if n is equals to 1, then even in that case, you will be returning 1. If n equal to 0, you will be returning 1. If n equal to 1 also, you will be returning 1, because there's only one way in which you can get to the first step. As simple as that. Okay, now this is recursion. Now, what is the time complexity of this? The time complexity would be O of exponential 2 power n. Now, since this is exponential, the time limit will be exceeded when you try to run the code. Now, why is it 2 power n? It is 2 power n because every time you want to try and call the function during the f of n, you have to call f of n minus 1 and you have to call f of n minus 2. You have to keep doing this for all the n iterations. So, for every n, you're calling the function for 2 times. So, by the end of finishing of n times, you will have to iterate for 2 power n times. What can you do to optimize the time complexity? What can you do? You can use dynamic programming. That's when dynamic programming comes into the picture. Okay? If the time complexity exceeds, that's when dynamic programming comes into the picture. Now, what do you do for dynamic programming? Now, instead of calling these functions every single time, you store the values of these f of n minus 1 or f of n minus 2 in an array. Okay? You store these values. For example, if I were to come across f of 2 and f of 1 again, and if something like that happens, if I come across f of 2 again, I'll have to do the recursion process once again, correct? if I come across f of 2 once again during some process of calculation, I'll have to do again, I have to start with f of 2 minus 2 plus f of 2 minus 1. And for f of 2 minus 2, again this will start computing the whole thing. But if I already have my f of 2 value stored in this array, why do I need to perform the action again? Correct? I don't need to perform this whole thing again if I have the function value for a n value stored. If I have the function values for n minus 2 or n minus 4 or for anything, if I have it stored, I don't have to repeat the whole process once again. So this will thereby reduce the redundancy and will save us so much time from repeating the same thing. So now there is a very simple way to convert a given recursion problem into a dynamic programming problem. Now, what did we do? If n is equals to 0, we will return 1. If n equals to 1, we'll also return 1. Okay? Otherwise, we'll return f of n minus 2 plus f of n minus 1. Correct? Now, how do we change this into a DP problem? Now, remember, whenever you're trying to create a DP array, always create an array with a size 1 additional to the n given indexes. Okay? Always create an array additional to the given n value, as in you will create an array of size n plus 1. You will create an array of size n plus 1. Now, why is that? It is because when we are going from 1 to n, we usually don't check for the 0th other than the base condition. We don't really need 0 to compute. For example, if you take the step 0 here, you don't have to go to the step 0, correct? Nobody will ask you how many distinct ways would it take to go to the step 0. We are only doing that because in case we were to compute the value f of 0, we should know how many ways it will take. So for the logic purpose, we have the 0 there. Likewise, for the logic purpose, you need to have an extra place to store the 0th value. So whenever you create a DP array, you are supposed to create the array with size n plus 1 to store the 0th value, to store the f of 0 value as well, meaning the DP of 0 value. Now, what are we doing? Since DP of n is equal to 0, you will directly, while writing it into DP, you will remove if n equal to 0 and you will directly write place dp of 0 is equals to 0, because you know that dp of 0 value will be 0. And likewise, if n equal to 1, you don't have to write that. You can directly initialize dp of 1 to be 1. Now, because you already know these values, so you can directly store them. You don't have to compute dp of 0, dp of 1 value again, since you know it will return 1. Now, since you're supposed to compute these values, since you're supposed to compute function of n minus 2 and function of n plus 1, you are supposed to find out those values with the help of this DP array. Now, what will you do? Now, you will write a for loop. Now, instead of directly returning it here, now after initializing this thing, what will you do? You will initialize a for loop. For I is equal to 0, I less than n, I plus. Now, what is n here? N is nothing but, in the question will only be given ki, okay, you have to reach to the third step or the second step or the fifth step. Whatever the n value is, it will be as it is. You have to reach here. So, for I is equals to 0, I less than n, I plus. Now, what are we doing here? We are returning f of n minus 2 and f of n plus 1 value. So, if it is f of n minus 2, then for each I value, so for each dp of I value, you will just replace it by dp of I minus 2 plus dp of I minus 1. Okay, this f of n minus 2 becomes dp of I minus 2 and f of n plus 1 becomes n minus 1 becomes dp of I minus 1. Okay, so for every I value, this becomes dp of I is equals to dp of I minus 1 plus dp of I minus 2. Okay, so every time this dp value, if there's dp of 3 here, okay, if there's dp of 3 here, then it will be dp of 2 plus dp of 1. Okay, now what is dp of 1? Dp of 1 is already 1. We know that. What is dp of 2? For dp of 2, you'll already have the value stored since you are starting from this thing again. If, okay, for your convenience, for your better explanation, if you want dp of 2, what is dp of 2? Already it will be dp of 1 plus dp of 0, correct? Minus 1, it's n minus 1 and n minus 2, right? So n minus 1 is 1, n minus 2 is 0. So what is dp of 1? We already have initialized it. Dp of 0 is 0, sorry, dp of 0 is 1. Okay, so dp of 1 is 1 and dp of 0 is also 1, correct? So dp of 2 becomes 2. Okay, so in this dp array, since we have it something 0, 1, 2, 3, okay, now we already have it initialized. Now it is 1 and this is also 1. Now we got dp of 2 value as 2. Now how do we compute the dp of 3 value? Now dp of 3 value becomes dp of 2 plus dp of 1. Now earlier what happened in the recursion function, when there's dp of 2, you had to again compute the whole thing. You had to again compute this whole function by recursion. Because of recursion, you would have to again split this part into dp of 1 and dp of 0. But since you already have the value stored here, dp of 2 as 2 here, you don't have to do this process again. You will directly be able to replace this by 2. Okay, that is the whole point of dp. Instead of again splitting it down into 2 other functions and 2 other calculations, you will directly be able to substitute the value. So this is what happens in dp. In the end, what will you return after all the values are filled here? After all, if dp of, when it's again the turn of dp of 3, its value will also be updated as 3. In the end, since you are trying to count the number of distinct ways it takes to get to the step n, you will be returning the value here. Okay, so you will be returning dp of n here. Okay, you will be returning dp of n. Now, what is the time complexity of this? The time complexity, since we are running an iterative loop with n elements, the time complexity for this dp would be O of n. It would be O of n. Now, what is the space complexity? Since we are storing an external array of size n plus 1, the time complexity would be O of n plus 1, which is equivalent to O of n. Now, can we optimize this again? Can we optimize the space part? Can we do this without using the space component here? Now, think about it. What did we do in dp? We had this letter n. So in the function, now we initialized dp array. Now how do we initialize it? You can either initialize the n plus 1 elements. You can either initialize this to minus 1 or you can initialize it to 0. But ideally it is initialized to minus 1 because sometimes for some conditions you will have to initialize dp of 0 to 0 and dp of 1 to 0. So in such cases it is suggested that you always initialize your array to minus 1. Okay. Next, how can we make this better? What did we do earlier? So we had dp of 0 is equals to 1, dp of 1 is equals to 1, and for int I is equal to 2, I less than or equal to n, I plus plus. This is not I equal 0, it is I equals to 2 because we already have 0 and 1 values. So we already have the I values, the dp I values. So dp of 0 and dp of 1 we already have. So we'll be starting our loop from 2. So which is why I've written int I equal to 2. We have a 0 value and 1 value. So we don't need those values. We don't have to find out those values. So we'll be starting our loop from I equal to 2 and I less than or equal to n. So we'll be going to the nth step and we'll be incrementing the count. Now, what did we do? dp of I is equals to dp of I minus 2 plus I minus or for your better convenience, I will write this as dp of I minus 1 plus dp of I minus 2. Okay, then in the end, you are just returning dp of 0. Okay, we are just returning dp of 0. Now, if you carefully observe here, at every given step, we are only considering the previous two values, correct? For every given I, we are considering only previous two values. We don't require I minus 3 value or I minus 4 value. If we are at I, we only need to store the I minus 1 value and I minus 2 value, and we are adding it and just sending the dp of I value in the end. So, if we store only dp of I minus 1 value and dp of I plus 2 value, shouldn't that be enough? So, at every given step, let me show an example. At step 1, what are we doing? We are taking the previous two value, then previous value and the current value. Okay, this is the current value which we are getting by summing these two. Now, when we come to step 2, we are consider, okay, now we took these three values. Okay, now what are we doing? When the current shifts to the next place, if this is current, then what is our previous become? Previous to becomes this and previous is this. So, we'll require these three values. So, whatever we have, it's this two. Then when we go to the step 3, now our current will be this, since this will move to this part, and previous will be this and previous 2 will be this. Correct? Okay. Now, if you see here, in every given step, we are only considering the previous two values. So, if we just store the previous two values until n iterations and return the sum of these two in the end, okay, and store these two and return that in the end, that should be enough. So, what can we do? We can first, let's store this previous two value, okay, previous two value as 1, because when I is equals to 0, when n is equal to 2, when we are at step 2, the previous is 1, previous of previous is 0. So what is previous of previous? Previous of previous is nothing but previous of 2, correct? And this becomes previous of 1, correct? And this is current value, correct? So what does this previous of 2 become? So this previous of 2, we know that dp of 0 is 1. So how many steps does it take to go to the step 0? 1. So previous of 2 is initialized to 1. Now likewise, in how many ways can we get to step 1? In one way. So previous of 1 is equal to 1. We are initializing this to 1. Now we have to find out the current value. How do we find out the current value? What did we do earlier? For the current value, we just added the previous values. So we'll start a for loop again, and int I equals to 2, I less than or equal to n, and I plus plus. Okay. Now int of current. Okay. Let's store this value as current. Now what does this current become? Current is equals to previous of 2 plus previous of 2 plus previous of 1. Correct. Now in the next step, what does previous 2 become? The previous 2 value becomes the previous, correct? So if you properly see, the previous 2 value in the next step is becoming previous. So here previous of 2 becomes previous. Now if you carefully observe here again, now what is the previous value in the first step becoming in the next step? It is becoming the previous current. Okay, the previous value in here is becoming current. So what will happen here? Previous is equals to current. Okay, the previous value is equal to current. Now after everything, what are we returning? We are just returning how the sum of those stuff, the sum of what it is taking, the sum of these things. So what is the sum of these things in the end? Since we are already updating in the nth iteration, the current value is already stored in previous, correct? The nth iteration, the current value is nothing but the sum of the previous two combinations. Since this is already stored in current, we will be returning the previous value after n iterations. Okay, we'll be we'll be returning this thing after n iterations. Okay, so let's quickly code this up. We have a function climb stairs given and we have an input n given where we have to reach to the nth step. Now, what did we discuss in the last approach about the space complexity? After optimizing the space complexity, what have we done? First, we took two previous values as previous 1 and previous 2 values. Okay, what have we initialized it to? We have initialized it to 1. So what is previous 1 and previous 2 here? It's just the, if you're starting at 0 and 1, we've seen that dp of 0 is equal to 1 and dp of 1 is equal to 1 because the number of distinct ways to reach to the 0th step or first step. So to reach to the first step or to reach to the 0th step, the number of ways that we are starting with is 1. Next, what are we doing? We are writing a for loop for I in range. Since we already have our two previous values here, so we'll be starting from 2. So we have our 0 and 1 values already. So we'll be starting from 2 and be going till n plus 1, because since we are starting from 0 to go to the nth value in the logic here, we'll be taking n plus 1, because if we write n plus 1, that's when the for loop will go till n. Correct? Now, what is the current value? Current value is nothing but the sum of the previous two values here. Correct? So previous of 1 plus previous of 2. Next, what are we doing? After moving forward, we know that the previous, in the next step, the previous of 2 becomes previous of 1 and the previous of 1 becomes the current. So the previous of 2 becomes previous of 1, like we've discussed right now. What will happen to the previous of 1? Previous of 1 value will be the current value, correct? The current value. Now, what are we returning in the end? We are returning previous of 1. Why are we returning previous of 1? Because this previous of 1 value is already storing previous 1 plus previous 2, which is the current value that's being stored in previous of 1. So, since it's storing the sum of the previous two values, we'll have to return this in the end. Okay, now let's quickly run the code. It is accepted. Let's submit it. It is accepted. Now, since we already spoke about the time complexity, it is O of n, since it's going through a loop of n elements. Then what is the space complexity? Since we are not using any external space and only using two variables of fixed size, the space complexity would be O of 1. Thank you guys.